equilibrium. Okay, welcome to today's class. For today, I'll help you solve question 4 of your tutorial sheet for chemical equilibrium. So before I start, just ensure that you subscribe to this channel so that whenever I post something, you'll be notified or updated. So let's start. So what's the question saying? So the question is saying, at a particular temperature, a 2-liter flask at equilibrium contains 2.80 times 10 to the power negative 4 mole of what? Nitrogen. And then we can see 2.50 times 10 to the power negative 5 mole of oxygen. And we are having 2.00 times 10 to the power negative 2 mole of what? Nitrogen oxide. Then the question is saying calculate K, which is the equilibrium constant at this temperature for the reaction. And then the reaction has been given where we can see nitrogen reacting with oxygen in order to form nitrogen what? Oxide. And this reaction is what? Reversible. In other words, that's what? Equilibrium. And then the question is continues by saying if nitrogen concentration is 2.00 times 10 to the power negative 4, it has been given. This is measured in molarity like that. And then we are having another concentration of nitrogen oxide given, which is 0.200 more like that. And then we are having the concentration of oxygen given, which is 0.00245 more. That's been given. That's a molarity. And then the question is saying, does this represent a system at equilibrium? So we are having two questions here. This one, the last part, which is asking us to determine or to show or to tell if this system is at equilibrium, and the other question is this one, the first one, which is asking us to calculate the equilibrium constant K. So before we tell them or we say if this system is at equilibrium, before we answer this last part, we can start with the equilibrium constant K by using this information on top there which has been given. So let's start with the equilibrium constant K. So our aim is to solve for the equilibrium constant what? K for the first part before we can solve this second part. And then what have we been given there? So there on top we are having the volume which has been given because it's saying a 2-liter flask at equilibrium contains. So we are having this volume which is 2 liter. Yes, that's our volume. And then what else are we supposed to do here before we solve for the equilibrium constant K? So before we solve for the equilibrium constant K, we need to ensure that we divide the moles given by the volume we are having here, the volume of the flask. So what are the moles given here? We are having the moles for nitrogen has been given, which is this one here, and then the mole for oxygen has been given, and then even the mole for nitrogen oxide has been given. So we will divide these moles given here by the volume that we are having. So let's start. So let's start. We are having nitrogen has been given. The mole for nitrogen has been given, which is 2.80 times 10 to the power negative 4 mole. So we divide it by the volume given, which is 2 liter, like that. And then let's do the same for oxygen. So oxygen, it has been given the mole for oxygen, which is 2.50 times 10 to the power negative 5 mole over 2 liter. And then the last part is nitrogen oxide, and then the mole has been given as well, which is 2.00 times 10 to the power negative 2 mole, like that, over our volume, which is 2 liter, like that. And then when we work out this on the calculator, with the first part, when you calculate, you punch that, we're going to get something like 1.40 times 10 to the power negative 4. And then that's concentration more over volume. That's a molarity that we're going to have. And then here on the second part, when you work out everything for oxygen, you divide on your calculator, you're going to get 1.25 times 10 to the power negative 5. And then on the last part, when you work out this on your calculator, you punch, you're going to get something like 1.00 times 10 to the power negative 2 and then the molarity has been given just like that. So once we are having this, we are not done. Now we can solve for the equilibrium what constant what K. Now how can we solve for the equilibrium constant K? How can you come up with the expression? Remember what I said in the video, if at all you watched the lecture on the chemical equilibrium, the introduction. I said the equilibrium constant K is the ratio of the equilibrium concentration of the what products over the equilibrium concentration of the what reactants. So I'm going to start with the product. So what's the product on this reaction? That's nitrogen oxide over the concentration of the what reactants, the equilibrium concentration of the reactants. So we are having nitrogen like that, and then we are having oxygen like that, and then each must be raised to their stoichiometric what coefficients. Like for nitrogen oxide, this one you can see 2 in front, so that's a stoichiometric what coefficient of nitrogen what oxide. And then for nitrogen you can see a 2 in front, that's a stoichiometric coefficient, so it must be raised to power 2. And then for oxygen there is no number in front of it, so same as 1, or just leave it like that. And then here we can substitute now. So our Kc is equal to, we are having the concentration for nitrogen oxide, which is this one down here. So we can put it here, replace it, that is 1.00 times 10 to the power negative 2, like that. And then over the concentration of what? Nitrogen, which is 1.40 times 10 to the power negative 4, like that. And it must be raised to power 2, like that. And then what's the concentration of oxygen, which is 1.25 times 10 to the power negative 5, like that. And then when we work out everything on the calculator, you punch proper. Also this one should be raised to power 2, like that. Then when you punch on the calculator, what are we going to get? We're going to get something like 4.08 times 10 to the power positive what 8, like that, without the units. So that's the equilibrium constant K, and as you can see, this equilibrium constant K is greater than 1, so which means the reaction is product what favored. So for the first part we are done. Now let's solve this second part. We need to tell if this system is at equilibrium, or not. So how can we tell that if this system is at equilibrium? So we're going to calculate the equilibrium constant K again for the second part using this different concentration. So we're going to use this concentration which has been given, which is 2.00 times 10 to the power more for nitrogen, and also this concentration for nitrogen oxide given, which is 0.200 more. And then you're also going to get this concentration for oxygen, which is 0.00245 more for oxygen. And then we're going to solve for the equilibrium constant K. And once we solve for that equilibrium constant K, we must compare with this one. If at all, if it's going to be the same, then we're going to say that this system is at equilibrium. But if it's different, then it's the other story. So let's do it. So let me lab before I can illustrate everything here. So okay, so before I lab, let me just maintain this Kc for the first part here, which is 4.08 times 10 to the power 8, like that. Then let me lab this so that I create some space down here, and then let me solve now for the last part. So for the last part, as I said, we're going to calculate the equilibrium constant Kc. So Kc, as I said, is the ratio of the equilibrium concentrations of the products over the equilibrium concentration of the reactants, and each raised to their stoichiometric coefficient. So the same. So the product we're having is nitrogen oxide, like that, and its raised will be raised to power 2 because there's a 2 in front there, over nitrogen, like that, and this one will be raised to power 2, like that, and on over oxygen. So yeah, oxygen, like that. And then what have we been given here? And then this one I'll differentiate it by using a prime, like that, because the first part we just use this Kc, then this one I'll just use this one to differentiate from the first one, this prime. Yeah. So for oxygen, for nitrogen oxide, the concentration has been given, which is 0.200, like that, and then this will be raised to power 2, yes, and then over we are having nitrogen, which is 2 times 10 to the power negative 4. Then this also must be raised to power 2, sorry. And then for oxygen, concentration has been given to 0.00245, like that. Want to tell if this system is at equilibrium. So after punching everything here, we work out everything. We are going to, on top there, if you square this 0.2, you are going to get something like 0.04 times 10 to the power 8, like that, over, when you work out this 2 times 10 to the power 2 times 10 to the power negative 4, you square it and you multiply it with 0.00245. you're going to get something like 0.0098, like this. And then once you divide this, you're going to come up with something like 4.08 times 10 to the power positive 8, like that. So as you can see, our Kc prime is equal to 4.08 times 10 to the power 8, like that. So this, the second one we have found, and the first one, they are the same. So Kc, this Kc prime is equal to the Kc we found at first. They are equal. So this simply shows that the system is at what? Equilibrium. So this system is at equilibrium because this Kc prime we have found on the second part and on the first part, they are what? Equal. So that's how you go about this, and I'm sure it's clear. And then if you have any questions, don't hesitate to contact me. And then lastly, don't forget to subscribe, like, and share. And thank you for watching.